Start. So first, welcome to everybody and to all that have joined our STARS webinar and tutorial dedicated to the Technology Innovation Analysis Part 2. So we will speak about smart asset management, maintenance of the future, and railways digital twin today. So my presentation will be to introduce you the agenda of our session today. So I am, first I can introduce myself. So I am Florence Mas-Bernat from Railenium, and I'm a Partnerships in Europe Director. So I will also introduce you the purpose of the Technology Innovation Analysis and a more or less large view of these two innovation trends we will illustrate today. So smart asset management and railways digital twin. So just to present you the agenda, so after my introduction, we will have as three main presentation. At the end of each presentation, we will have a small session of questions. So of course you can put your questions during in the chat, and we will try at the end of this session to answer to them. So the first presentation will be done by Network Rail, so the UK Infrastructure Manager, and Railenium, the research innovation center dedicated to railway. And it will be on how smart metering can improve railway energy systems. So it will be presented by Smail Ziani, who is Railenium Energy Conversion Manager, and Brian Leia, who is Network Rail Senior Asset Engineer. So you will hear about the electrical energy conversion challenges and how smart metering will help to manage this, and what are the interesting gains for the infrastructure manager, and further how to implement the industrial solutions. Secondly, we will have the presentation from Eurostep Group, so related to asset management for railway infrastructure and digital twin. That will be presented by Sylvain Marie, who is the A&C Plant Industry Vertical Director, and you will also learn about the asset management changes for infrastructure and how extended enterprise and open standard will bring some important solutions and illustration among also major engineering actors like Aegis and Sistra. And then the third presentation will be done by Railenium again, and it will be on the digital twin and artificial intelligence for railway sector. So presented by Nasiba Keladi, who is BIM Manager, and Anko Madani, Artificial Intelligence Manager. So they will not be part of the session. So we will have a video they made, they presented, and if you have questions, they will answer after it, because all the session will be registered on the STARS platform. So thanking very much the speakers for the presentation, where we should, of course, illustrate practically what the advanced technology could bring to our technology innovation challenges for railways. And this was precisely the topic of the technology innovation analysis that was done by Railenium for the STARS project. So the goal was to aims to provide the SMEs an overall picture of the railway major innovation trends and advanced technology paths that are associated and needed. And so this should help them to be more aware and enhance their capabilities to adopt advanced technologies, as well as to better understand what are the railway industrial changes and innovation roadmap. And perhaps also highlight some aspects like skills that we should need, for instance, to drive those innovations. So really the aim of this tutorial part, so we have 4 parts because we have 8 innovation trends, and we divide it in taking 2 by 2, and it's to illustrate, including testimonies of major railway sector actors, and from this it aims to constitute relevant information bases to help and provide SMEs information. So this is completely in the goal of the STARS project, which is to boost SMEs in the rail sector with advanced technologies. So just to summarize the methodology and the main major step we use. So we had 4 steps, and we started with the state-of-the-art from the wool R&D industry and an expert of this railway sector, by taking some very well achieved innovation roadmap, like from ERAC, like the SRIA, so the Rail Strategic Research and Innovation Agenda, and like Europe's Rail program, with bringing a lot of those innovation ahead. And the second step, starting from the state of the art, was to extract the innovation trends and the technology changes associated. Then we list those technologies that are supposed to help to answer them. And we finally found out some 8 innovation trends and like 37 technology changes, both on hardware and software aspects. And at the end, the 4th step was to try to propose some key indicators. So basically, we try to make it simple, retaining 3 of them. So the time to market and level of maturity of technology on time, the key skill that should develop by SME to support this innovation, and the budget effort that you should need to engage it. It should be from low to very high, of course, for these indicators. And at the end, we gathered all the information within the matrix, where you can find the detail per innovation trends of all those elements. And today, so we will address, you see the 8 innovation trends are not detailed, but we will address 2 of them that are in fact complementary and about smart asset management and railways digital twin and simulation. So just to introduce you a large view, and you will have then the more concrete with the speakers explanation about those topics. So what is in this field? So first, on smart asset management, you can see that the digital technology enablers are really key to boost this area and allow to explore the potential of predictive maintenance. So, of course, all the time we speak about IoT sensors, data collection, data analysis, software, and intelligence, artificial, and so on, that will be needed altogether to answer those challenges. So, for instance, we will have to develop interoperable devices integrating self-diagnostics, but also that will be necessary to have a very small consumption of energy. And this will help, for instance, to monitor critical asset functions, like you can find on rolling stock, like wagon braking systems, but also to measure loads, bad dynamics, or critical vibrations. And this will be based also on IoT networks and sensors. So we will have also to develop the software platform to be able to manage all those data in real time, so implying data fusion algorithm, coupling diverse sensor and data for diverse operation condition, machine learning algorithm to predict failures, and be able to trigger maintenance intervention. So we'll need also, as I said, to have autonomous embedded systems. And for this meaning, for instance, we need to develop energy harvesting devices like new kinds of antenna converting electromagnetic energy into electricity, for instance, or new materials. So some other important aspects will be to develop highly performing inspection tools to increase operation efficiency, reduce inspection times, reduce staff involvement. And this will need interoperable format and real-time results also to be sent to customer, but also, for instance, remote inspection HMI devices that should be based on augmented reality or natural language. And also each time we have IoT networks based on embedded sensors. So we can see accelerometers, speed, temperature, for instance, and they will be both on rolling stock and on infrastructure, on rail, bridge, and signaling or switch that are a sensible asset to monitor. And of course, we should think also about to have a clear planning to make maintenance intervention and just on time, and really dedicated to the good point where of this intervention. So we should need also robot application, not for all, but for different use cases. For instance, when you need to increase the workers' safeties or reduce injury in maintenance dangerous or repetitive tasks. And then we should design those robots, for instance, to repair automatically infrastructure assets like rail or catenary. And it will also, for all this application, we also will need to have new wireless network backbone for trains. So don't forget the telecommunication, for instance, 4G and 5G that is coming and will provide a strong gap within the communication railways, because all these are facing higher and higher capacity to answer new services demand. And you will need to have, for instance, very high power transmission emitters for the real-time data transmission, but also to secure protocols to be designed under cyber attacks and to be robust to any kind of modification. And the question of spare parts will be also addressed because tomorrow we will have more and more products and a diversity, shortening the life cycle of them, and this should be also accelerated by our digital technology in order to manage the spare parts on demand. Coming now to the focus more on the railway digital twin, this will be really important to develop this to support the asset management, and specifically designing a process that will cover the design to the operation on the whole life cycle of the products. So covering operation requirements, exploitation, and maintenance. And this also will involve, of course, the advanced technology like big data, artificial intelligence, but also modelization and simulation platforms that will be linked to physical sensor network. So, for instance, the aspect of the BIM, that is important, modeling as a basis of the digital twin that will help to design, plan, and execute and monitor the equipments. And we will need, for instance, to have a link between the CAD models and the BIM data format like IFC, and to have a very high quality of data and BIM processes, but also to develop conceptual and interoperable data models, also supporting data exchanges, and also based on data dictionaries and ontologies that will be very precise in describing the nature of the data. We will also have the need to develop the global modular digital twin platform and to integrate really a highly modular computational representation of the digital twin architecture. So that we need to develop and provide appropriate networks and frameworks. And at the end, also to automate the design. It's really, it will be very important in planning processes. So to be able to monitor different kind of assets and map them on a specific region and really allow to develop predictive maintenance. So this was just to introduce the global picture of it, these two innovation trends, and express how the advanced technology will be more than a contributor, but enabling to manage a clear gap of innovation in these domains. And now I will leave the floor to the next speakers to go more in the application and let you know more about how to manage those aspects. So maybe now I'll just escape. And Ismail, and if you can take the floor, Ismail and Brian.
Thank you. Yeah, thank you.
Thank you very much.
Yeah, I just shared the presentation of you, but if you prefer to share by yourself, please do so.
If it's possible to share my screen, it will be maybe preferable if it's okay for you.
Yeah.
I will do it. Tell me if it's fine, and if you can share if you can see my screen. Do it. Presentation mode.
Perfect.
It's fine. Perfect.
Yeah.
Perfect. Thank you. Thank you, France, for the introduction. The aim of my presentation is to explain, or to try to explain, how smart metering can improve railway energy systems. I will be accompanied with Brian, of course. I will start the presentation. After that, Brian will continue the presentation to talk about other subjects. The results of my presentation are from the Into Tempo project. It's a shift to rail project, and now it's Orbs Rail. So I will start to present maybe some results from this project Into Tempo about smart metering, and after that I will give the floor to Brian. Perfect. So I will start to present the smart metering use cases. We have three use cases for the smart metering. We have the first one. It's a commercial operation use case located in south of London, UK, and dedicated to the Tonbridge Red Hill line. It's a 750 volt DC line and led by Network Rail. The aim of this use case is to improve the mapping of energy flows dedicated to the railway system in commercial operation. And I think the novel approach is to have or to obtain a data synchronization between the rolling stock data and the infrastructure data. And like this, it's possible to have a better understanding of the energy flows. The second one is located in Zaragoza, in Spain, and is dedicated to stationing and maintenance operation use case. We are talking about Zaragoza tramway. It's like the first one, 750 volt DC line, but here we are talking about a classical contact between pantograph and catenary. The aim of this use case is to improve mapping energy like the first one, but here we are talking about more about maintenance, depots, maintenance facilities, and to understand better the energy flows. We are also talking about to improve maybe the maintenance using, of course, new approach like using predictive maintenance or machine learning. We will talk about this after in the results. And the third one, the last one, where Brian is the leader of this one, we are talking more about electrical infrastructure use case. It's also located in London, UK, like the first one, and dedicated to the line London North West Coast Main Line. And here we are talking about 25 kV 50 Hertz system. So here we are talking more about detection of electrical anomalies, and I think the most important part, it's about using continuous monitoring. And we will see after how it's possible to do it with some novel approach about acquisition systems. Of course, we are talking also about a better knowledge of energy mapping, but here we are talking about 25 kV 50 Hertz, so it's another system about the first and the second one. Okay. After a very quick introduction, I will talk about globally what is smart metering. So the idea is to start from the sources. So here, of course, we are talking about the infrastructure and the rolling stock. Of course, we need to use sensors and also smart meters. So sensors to measure directly the data. So here we are more talking about electrical data like current and voltage. And we need, of course, the smart meters. So we'll see in the next slide about acquisition systems and gateway, etc. So after I just talk about the sources, we will need, of course, to collect this kind of data. An important point is the synchronization of the data. After that, analytics. Of course, we need to analyze the data to see what is useful, to create some indicators. And by the end, what is important is the user applications, of course. So we need maybe, for example, to talk about dashboards, how we use these indicators to understand better, for example, the infrastructure, and maybe also the rolling stock. Okay. So, of course, if we are talking about smart metering, we need to talk about the hardware part. So, of course, we need to install or to implement the sensors. Here, for example, we have a GPS. We use this kind of GPS in the rolling stock for the use case 1. Here, for example, we are talking about the use case 2 with the CAF. So here it's possible to measure the mechanical tension in the catenary. So Rogowski calls classical sensors to measure the current. And of course, the main part, I will say, is the acquisition system and how we get the right data with the right sampling frequency and how it's possible to create also some indicators. Okay. Now I will talk more about the architecture, about software. Of course, it's necessary to get this kind of data. For example, here we are talking about, of course, electrical measuring and GPS data. We need, of course, messaging, processing, but like a user, like an engineer, of course, the main part, the most important part for us is, of course, the storage and the visualization of the data. So for the project Intus Tempo, we are talking about InfluxDB database. It's very useful. We will see why in the next slide. And we use about the visualization of the indicators or the raw data. Grafana, it's an open source tool and very useful tool for the users or like an engineer. Okay. Now I will just present or introduce quickly first results. I introduced before the dashboards. So a dashboard is very important. Here we are talking about use case 3 with network rail for a substation, for the infrastructure, for Bushi feeder station. And here we have a live view about the different data we have. It's a global view to understand what we can measure, how the infrastructure, or how the substation, what kind of energy we have. For example, here we have all the feeders. We have the information about the current. We have also, of course, the RMS value of the voltage for the catenary. It's interesting. And some kind of indicator. So we are not talking about raw data here, for example, and it will be very useful. We will see after that why. For example, here we have the THD of the currents that represent the distortions, the harmonics of the currents. Oh, it can be explained by the quality of the currents, and when the value is high, that means that the quality is not very high. Other indicator, interesting indicator about the power factors, it's also important. And I will continue to present now more precise aspects about the impact of smart metering. So I will start what Florence talked about. So asset management. So here we will start to talk how it's possible to detect some fault in the catenary system. And now I will talk more about how it's novel, the acquisition system of use case 3. If you need to understand better what kind of fault you have in the catenary, you need to have raw data. If you are talking about raw data, we are talking about high sampling frequency of data, like more than 10 kilohertz. So if it's necessary to make this kind of acquisition, it's not possible to do it all the time. So it's not because the amount of data it's too much important. So you need to find solution to have the data when only it's necessary to do it. You can imagine to use a classical approach with a low sampling frequency of 1 or 10 hertz, just to measure the energy, I will say, to measure the current and the voltage and to understand better the energy flows. And when it's necessary to have a high sampling frequency to get the raw data, like here, for example, here we have the current and the voltage, we will use some triggers. So if you have a high value of current and a low value of voltage, we will start to make the acquisition. I will give you an example. For example, 10 seconds before the event, during the event, and 10 seconds after the event, just to have this raw data to make some analysis. So here, for example, you have a list of some low voltage alarm and a high voltage, a high current alarm. Here you have the raw data of the current and the voltage. And after that, we will use this kind of data to calculate some interesting indicator. So for the fault detection of the catenary system, we will use the data from the database, and we use Python to use some novel approach to have a better accuracy for the calculation of the impedance, because the impedance is a very important indicator to understand better what kind of default we have. So we use an instantaneous phase shift to have an instantaneous impedance. And we use, of course, Python to do it. And we will have the automatical link between the InfluxDB database and Grafana to have this kind of information of the impedance. So it's very interesting because like this, it's possible to have important amount of data about events. Well, I think we have more than 18 months of data of current and voltage and impedances for this kind of faults. I will continue to introduce some impact, some results about smart metering. So now we will talk always about asset management for the use case 2. Here we are talking about more about track switches failure detection, and we use some machine learning approach. Here, for example, you have the measurements of the current from Rogowski coils to have some patterns. So here you have expecting the operation. Here some anomalous cases, and like this, it's possible to have some alarms. Here we have another approach, more about energy. And using machine learning, it's possible to have some patterns. And when we have some abnormal cases, it's possible to have the information. I will move, so another kind of impact. Here we are talking about more demand, so more about energy. And it's a very interesting and I think, impact or use case, because we are talking about regenerative braking energy, and especially about the DC part, of course. So here, this use case, it's for the first use case. It's for the Tonbridge railway line. For the DC line, and we propose a new approach to quantify the energy braking. The idea is not to use, because the classical approach is to use the measurements of the speed and the current and the voltage from the rolling stock. Here we propose only to use the data from the substation and only the current to understand or to identify the energy braking using, of course, the patterns and some kind of machine learning approach. And like this, it's very interesting because we will have a smart approach. We use smart metering to reduce the numbers of measurements. And like this, it's possible to quantify very quickly and with an easy approach the energy from the regenerative braking. And like this, it's a first step, I will say, to know where is interesting to have some energy storage like batteries in the infrastructure. Okay, also always about the demand. Here we are talking about the Sankey diagram. It's a very useful tool because like this, it's possible to understand better the energy flows visually using Grafana. For example, here we take the example from use case 2 from a substation from the Zaragoza tramway. So we are talking, I think, for the substation 5, where we have, of course, the group rectifier, rectifier group 3. This rectifier group 3 is dedicated to the maintenance depot. So we have a feeder dedicated to the depot. We have the energy, the amount of energy, because the thickness is the energy, the consumption energy for the depot, also of the workshop. But what is most interesting in this kind of Sankey diagram is we will have quickly an information and an idea about the losses. So it's very interesting. And the second step, when we would like to use this kind of diagrams, it's very useful to understand quickly and to develop some patterns about abnormal consumption. Okay, Another interesting impact. So now we will talk more about software modeling. So of course we need to use simulation, modelization to understand, to quantify some energy flows. But of course, real data have an important impact. For example, here we have a speed profile from a train, from the modelization, from the simulation tool, and here we have the real data. And like this, when you have real data, it's possible to validate our modelization, but also it's possible to improve it or to modify some parameters. So the real data from the Intertempo project, from the 3 use cases, are very useful to validate and to improve our tools for the rolling stock, but not only, also for the infrastructure. I will give you the floor is yours, Brian. You can continue the presentation.
Okay, thank you. As Mel explained before, my name is Brian Leah. I work for Network Rail. We're part of Intertempo, mainly as the infrastructure manager. Our interest was basically on the basis
ya hay muchas entidades que ya conocen a las dos. Entonces, el estar...
Okay, sorry. Yeah, our interest was basically on the basis that there is many benefits that we can achieve through smart metering. Some of the systems, you may find that there are some products that are already available in the market, but we believe that the approach, the use cases that we're trying to implement via Intertempo could actually offer an integrated solution which covers many areas, which some of them we're highlighting here on the slide. Some of the things that we're looking at was mainly energy management, where we believe through smart metering we can be able actually to see how our traction power systems utilize energy, or where there's losses, we can be able to optimize it. But the key thing that we're actually looking at, the principle under Intertempo, was to have non-intrusive equipment on site. Basically, it means the installation of that equipment doesn't affect the operational railway. It's simple and it's cost effective as well. And some of the benefits with this is, with modern technology, we can have equipment that comes with time synchronization, which is GPS linked, and we can have equipment on different substations which are synchronized, which talk to each other, and they can also talk to the rolling stock, which means we can fully understand the energy flows within the system. And some of the things that we actually anticipated, which could actually solve real problems that we have, or real situations that we have, is being able to use this data to help detect faults within the system, or anomalies, which even though we've got protection systems or we've got legacy instrumentation, we believe the combination of online data and application of tools, software, including AI and machine learning, can actually be able to improve the manipulation of this information and help in terms of decision making, being able to quickly identify faults, or being able to trend where we've got transient issues, or being able to capture the data for use as an asset management tool. And also being able to utilize this information for condition-based maintenance, to optimize maintenance, or to optimize the overall management of the asset. We also anticipated that we can actually be able to use this information as well to augment or to support the legacy modeling tools that we have. So for example, for timetable planning or for capacity planning, we can actually compare the information that we get from the modeling software with what we're actually getting on the ground. So for example, some of the metering that we have could be commercial metering, which in our case, sometimes it only measures at 30-minute intervals. But this system actually is, we are able to actually see the information or see the energy flows at even more frequent, at the higher sampling frequencies, and being able to see the real-time information. So for example, we won't be able to miss peaks where, if our capacity or if our demand is more than the capacity, we can be able to see the times when we have those situations, which enables us actually to optimize our timetable or to identify the hotspots or the trouble spots and optimize our system so that we can either optimize the capacity or to help make good decisions in terms of where we need to strengthen the system. Okay, if you can go to the next slide, yes, ma'am. So one of the things that I'll talk about is yes, this has been a use case, particularly for use case 3, we did install the equipment on 3 locations near London, simply as a use case, but we have actually managed to use this equipment to help us in dealing with some issues that we have. We can actually see the energy flows that occurring on the system, and we have actually been able to use this following a fault that affected the catenary system, as shown here. On the left, I can see we've got legacy equipment, like the legacy SCADA system, which is still able to show us when the circuit breakers operated, and we've got the protection relays, which can calculate some information, which can give us some information as to when the fault occurred, the approximate distance to where the fault was. But the issue with this equipment is most of it is legacy. It's a bespoke, so it's not easy from an asset manager point of view. It's not easy to actually optimize it or to change it if it's not accurate, and it's not time synchronized as well in some cases. And so for these protection relays, you may actually need the maintainer to go on site to be able to get this data, which is time consuming. So in a case where we've had a fault, we need to be able to respond we need to have all the information at hand and be able to respond, to use that information to speed up our response to restore the system. So you can see here on the right, we have used the information from the smart metering equipment that we've installed to actually help visualize what actually occurred on that occasion. Even though we've got information on the left from the legacy systems, this one is clear to us. We can actually see the currents, the voltage performance at that point, and how the protection system operated, whether it's normal or there's some issues. You see from the next slide that on a recurrence of on that same location after the circuit breaker had reclosed, you can see here that the voltage after the protection system operated, we didn't have the voltage recovering, but there was a sustained high impedance issue, which under normal circumstances, looking at the information on the left, it would have been difficult to see what exactly transpired. So we can now explain that because of this sustained fault, because of a combination of other issues that we're not aware of, we're able to determine that, oh, there's an issue, which explains why the catenary melted in the first place. So in summary, this system is quite helpful. It gives us a lot of visualization, gives us a lot of information. We've got other examples, which some of it you have seen from Smell there in terms of even regenerative braking. We can also look at things like THD, the harmonics. We can actually be able to record disturbances that are not necessarily resulted in the protection system operating, but things like where you've got arcing, you've got the system being disturbed, you've got transient high voltages or transient overcurrents. We can be able to detect the situation, and which can help us determine the condition of the system. All right, the other thing that I'm going to speak about is, so now we've got the system. What are the next steps that we need to have the system, to fully utilize the system or to roll out the system? Within Network Rail, we've got a framework called Rail Industry readiness levels, which we use to test products or processes if they're coming in through R&D. So when we've got a system, we test it using various parameters, including things like how ready is the technology, how the system integration, what's the readiness in terms of system integration, what's the reliability of the system, is there any demand, or what is the market readiness of the system? So with this equipment that you've installed via this case, we have tested it as well using all these parameters, and they test the product or system looking at different stages from conception all the way to rollout and whole life management of that equipment and through to maintenance. So we've tested this equipment looking at all these parameters. In some cases, there are some elements which should have been advanced. For example, technology. We know that in some cases we have used for this use case, in some cases we've used off-the-shelf equipment, discrete off-the-shelf equipment like data loggers. But things like software or the tools that Smail explained, the tools that we use to calculate things like distance to fault, or the tools that manage the data transfers from the field all the way to the servers, those could be new tools that may be lower in terms of how ready they are for the market or for rollout. So I've shown you here as an example some of the things that you looked at, and then we provide evidence, we make our own assessment, and we present that information to R&D board, and we come up with an overall indication of what that overall readiness is. And depending on where we are in terms of whether we are on Rail 1 to 3, Rail 4, Rail 5 and 6, and Rail 7 to 9 is actually when the system is ready to roll out to industry, or where we can actually ready to apply it within Network Rail to other locations, to other sites, or to commit to investing into it. So depending on where we are, we've got stage gates that allow us to make decisions in terms of testing whether does it meet the requirements of the railway, has it been fully validated, is there a business case for it, what are the assurance requirements. So at each of these stages, for example, in the case for the Intertempo use cases, for example, we could have determined that overall we're at rail level 3, which means we have to test it at gate 1. So if we've tested it gate 1 and it gets approval from the board to say, yeah, we can go ahead, we commit some investment that is required depending on what the need is. It could be things like maybe we're saying the reliability of the integrated system still needs to be worked on. Then we can then put action plans to work on those items until we're at a stage where we can say we can go to gate 2, and then finally we get to gate 3. Once we've got to gate 3, then we can roll out throughout the system wherever there's need to do so. Yeah. If you go to the next slide, so from our assessment for the use cases that we involved in, some of the things that we noted, or some of the considerations that we've looked at, is things like integration, because Intertempo was composed of many different teams, each contributing their own part. Obviously, integration is a main issue. We've got hardware being provided by other teams. We've got configuration on site being provided by other teams, and then also at the end of us as users, we need to be capable of being able to configure the system. We need to be able to manipulate the system, or to operate the system, or to see those visualizations. The other bit is the main aspect of Intertempo is the use cases is non-intrusive, which is a big win for us. We always want a system that we can install everywhere without any issues or without having to take outages on the system. And there's also the software, which I've touched about, that most of the software, we've got software that deals with how the data is encapsulated on site before it's being transmitted. We've got software that manages the collection of data online on the server. And then we also have got software that is being developed in terms of tools. Some of the tools that you saw there in terms of how we calculate the distance to fault. We also got tools on site that manage the protocols to change from one protocol to another, or the compression of data. We've got two data streams. We've got continuous data, which is sampled at lower frequencies, whilst we've got targeted information which only looks at when there's a fault, which in terms of this is required to actually optimize the amount of data that we transmit, because we are not using optic fiber, or we're just using normal data networks. The other aspect is reliability that I've touched on, which is a key issue, because we want the system to be fully reliable, or to be able to recover as quickly as possible if there's any issues. And also the issue in terms of market, we look at the cost. Some of the equipment that we used may have been a little bit costly. For example, the data logger, which is something that we'll need to optimize on. And then there could be also the market may also catching up with this equipment. Like there could be discrete systems within the system that are competing with this, or maybe new products in the market that also does whatever this equipment, most of what this equipment can achieve. So that's some of the things that we need to take into consideration to say, whilst trying to develop the system, are there any other alternatives within the market that can actually cover this gap quickly? There's also cybersecurity issues, which in this case here, I don't think it really affects us that much, because it can actually be a positive, because the operational systems like the SCADA systems or the protection relays, which can do some of these functions, they may have issues because they are operational, they affect the railway. So we may not be able to allow everyone else to have access to the system. It could be just an operational tool which is being used by control room only, but the asset managers and maintainer may not have access. But this system, the smart metering via Intertempo, it doesn't control the system, so there's no limit in terms of who can actually access the system. And finally, talking about demand, following from the examples that we have just shown, we've managed to test the interest within the teams within Network Rail. There's a lot of interest. We think there will definitely be demand, because we can be able to demonstrate that useful functions of this tool, particularly the example that I just shown, where we've used it to define the root cause of a fault that affected the system. Okay, I think that's it. Yeah.
Thank you very, very, very much, Ismail and Brian, for this very nice presentation. I think we are perhaps running a little bit of time now, because we plan to finish in 1.5 hours. So if we can just perhaps answer very quickly to the first question about it, and then we will perhaps answer later on on the platform on the other question, because we will be running out of time. Okay, so maybe just the first question, if you agree, Ismail, to answer.
Yeah, of course, yeah. And please, Brian, if you want to add something about this,
Oh, Brian, yes, sorry.
But
Yeah,
I will be quickly.
Okay.
Yeah. The idea, yes, is to how it's possible to detect fault in the catenary. The most important thing is to have amount of data. So we need to have raw data to have the current and the voltage with high sampling frequency of data. And like this, it's possible to calculate the impedance. Because if you have just low frequency or low sampling frequency, it's not very easy to improve the approach. And I think the most important thing to know is it's not possible to make, for example, 10 kilohertz sampling of frequency, high sampling frequency of 10 kilohertz for all the day with acquisitions. It's not possible to do it. So the idea is to use triggers. So like with the triggers, it's possible to make acquisition only when it's necessary to do it. And it's very important information, and it's also very novel. For the hardware part and also the software part. And like this, it's possible to have many events. It's possible to have an important amount of data to analyze and to improve the calculation of the impedance, and like this, to have the good location of the event.
Okay, thank you.
We have one
Yes.
or two questions from the chat. Maybe a quick answer to this last question.
Because it's a simple question. Is a smart metering system a system that is permanently installed?
I will start, and maybe Brian, you can continue. It depends. It depends of the use case. Maybe, for example, if you need to quantify, for example, the energy breaking, and you would like to know where is interesting to install some storage like batteries, it's not necessary to have continuously or permanently the installation. The idea is to analyze for example 1, 2, or 3 months, and after that you can use this kind of smart meters in another site, for example. Brian, please, if you have maybe
Yes, I agree with you. Yeah, because it's non-intrusive. It's designed to be very simple and portable. You can, if you've got an interest on a certain location, you can quickly go and install it there, monitor for a while, and then once you've got all the information you need, you can, if you no longer require it, you can remove it and use it elsewhere, because it's non-intrusive, it's quickly to install. Or if required, you can keep it in there for forever, because it shouldn't be very expensive as well.
Okay, and another question was, where are they being installed? In every substation, in every vehicle?
Interesting question. Yes, it's very important, because here we are talking about smart metering. In smart metering we have smart, so it's necessary to don't install for each substation. For example, if you have for example 5 substations, the idea is to install maybe 2, and to complete the information by machine learning or something like this, to have the good understanding about the energy flows, for example, for all the line, but only using some smart meters only for 1 or 2 substation, and use some smart approach like machine learning to understand globally the energy flows. This is the approach of smart metering.
Okay, and finally, do we need to comply with the standard EN 5463?
This one is for you, maybe, right?
I think it comes to the point now when we think of mass rollout of the equipment, then that's when we'll test all the issues about compliance and any other requirements. But for the purposes of testing the concept or the use case, or as a use case, we didn't really look too much into that detail. But when it comes to a point where we have to roll it out, we have to ensure that we do those compliance checks.
Okay, great. Thank you very much again for your intervention, and we see that we had a very interesting debate. Can we move to the next presentation from Sylvain, if you're here, Sylvain Marie, to take the floor, if possible? Great.
Good morning.
Good morning, Sylvain. Thank you very much. Let you the floor.
Thank you, Florence, for this invitation. We'll spend a few minutes talking about asset management for railway infrastructure and digital twins. And I think I have material for 2 hours, but we'll spend only a few minutes. I'm Sylvain Marie, Director of AEC and Planned Industrial Vertical, and I'm working with Eurostep. Eurostep is a European company founded in 1994. We're based in Sweden, UK, and France. We operate in defense, manufacturing, and in the AEC domain, which is will be our focus point for today. Our core business is to provide software for control data sharing across the product lifecycle and to manage a change across extended enterprises with a mixture of diverse systems. So today we'll talk about asset management, digital twins for railway infrastructure, change management, extended enterprise, controlled collaboration, and CDE, meaning common data environment. So we have a perfect bingo because those terms are repeated everywhere, every time, but this bingo will be debunked, I hope. I will provide you with a few pointers to know more. First, a few pages on asset management challenges for railway infrastructure, and it all gets back to asset management, the famous ISO 55000, which is rather well represented by this slide. You have the asset information at the bottom, the risk and review, and this is what you want to convey. That's your added value on the right, your orange box. And of course, you have a few organization and people interactions on the left. The most important figure, though, on this slide is the blue cycle, the acquire, operate, maintain, and dispose cycle, because this is repeating and this is impacting your asset, and this is where problems arise, and we'll see why in the next slides. So again, ISO 55000, that's the basis for asset management, and you always should get back to this slide. So if we consider asset management, dreaming of railway infrastructure, the bad news is that you're caught by change management. You can't do asset management without addressing the change management. And that's the first fun fact for this presentation. Traceability, proper traceability requires change management. So you thought you were all set with the previous slide with the ISO 55000, but no, you need to address change. So what's change? But what's an asset first? If you consider this as an example asset, representing asset for a railway station, well, first of all, that's a 3D model. That's not an asset, and that's different between geometry and BIM, but that's not the subject of this presentation. So let's consider this asset we want to manage. First, the asset is multifaceted. You have a multiple of systems. Will it be catenary, passengers, civil works, network topology, signaling, power? This is what you really manage, and that's your real asset and not the 3D model. So we'll start from the end and consider the physical twin. And to manage this physical twin, we have an asset register. Asset register is one of the keywords when you do some asset management. You want to have a synthetic, accurate, up-to-date view of your assets. In between, you have the digital twin helping you to have the asset register. And the link between the different twins is the IoT. That is where the information is flowing from the physical world to the digital world. The question is this digital twin accurate enough, up-to-date enough to be considered as an actionable asset register? For this, we'll describe what's happening on the physical world. You have the operations, day-to-day operations, ongoing projects, maintenance, usage, wearing projects, and so on, and all the activities impacting the physical twin. These operations need to be reflected on the digital twin just to make sure the digital twin is up to date. And then you have the design operations, the design changes, the remodeling, all the changes happening on the assets. And finally, you have the asset management activities. which enables you to do some impact analysis on the digital twin. If we map at a lower level, granularity level, you can have change requests or problem repeats happening on the physical world, which triggers what-if analysis. These analyses provide or delivers change proposals. Then you select one change proposal from these entering incoming RFIs or requests for information, and then you prepare the work order package. This fifth step triggers the project work order, which itself provides the design solution, which triggers procurement, which triggers the build phase. And that build phase is really in the design phase, and it also impacts your digital twin. And finally, this design phase impacts the physical twin by the change notice, which is the real activities happening in the real world. So with this chain of actions, you really have the traceability you need to make sure that your asset register is up to date from the physical world to the digital world to the asset register. But meaning the slide is the main purpose of this slide is to convince you that you cannot have an up-to-date asset register when you don't have a proper traceability on the left. So you have to dig in and to go on the lower level to make sure that you address the traceability for every of those actions. Now, what about the impact analysis? An impact analysis being if an input requirement is changed, passenger capacity, topology change, whatever, or if a new technology is to be deployed, what are the impacted capabilities, functions, derived requirements, subsystems, and I could go on and on with those link of consequences. The key point is that the impact analysis has to map all the impacted activities. And also, what are the impact or the non-impact on other assets so that they are declared reusable? That's the whole question of impact analysis. But again, that's the trap. If you consider the railway infrastructure with the asset management, we already seen that the change management is required to do some proper asset management, but the data consolidation is really key to make sure that the change management is possible so that you can manage the assets. What is data consolidation? It's a way to make sure that you don't compare apples to peers, but you rather compare comparable data because they share the same data model. And that's a glimpse, small snapshot of all the data models in play for railways. On the left side, you have rather the design phase. And if you add to the mix ULINX, IFC from Building Smart, and other standards. And on the right, you have all the, let's call them runtime models from RTM, or anything related to UIC. The key here is to make sure that all these data models are comparable, that you can action all the models in the same time to provide you with the proper input for the impact analysis. So those models, those are the fuel to create a digital model or digital twins. But what is the digital twin ecosystem about? Here I represent the evolution of the digital twin with the two wheels. Really, you have the stable wheel on the right, a built asset operation phase, where you operate, where you maintain, when you create some analysis and you investigate the deviations from the strategic plan. That's the stable wheel. On the left hand side, you have the rather faster wheel on the project delivery phase. This is where you do some requirements to change your model. You define a solution, you realize the solution. After you selected the one you want to implement, then you validate and you archive the project. On the right, that's the asset information model. On the left, that's the project information model. And the fun happens in the middle. That's where you need a system to coordinate and to align the speedy wheel on the left and the stable wheel on the right. Now, if we talk about, we'll avoid name droppings, but still mention a few software. If you add IoT to the mix, these platforms or softwares could be considered as contenders. On the project wheel, you could, as a reminder, you could think of Trimble, Autodesk, Dassault Systems, and Bentley. And on the right, you have a Maximo, or you have all the CMMS systems, SAP, of course, Power BI. The question is how to make sure that to orchestrate all these softwares. So the answer, of course, is to make sure to align your data models. Digital twins are here to close the gap between condition-based maintenance driven by IoT and capital asset management driven from the right with the risk management, configuration management, and what-if analysis. So that you need not the ecosystems, but you need standards. And as a reminder, I'm sure you've all seen this already from XKCD. You have 4 competing standards, but hey, that 14 competing standards, that's ridiculous. We need to create a new universal standard that covers everyone's use cases. To be a good idea, but soon you only end up having 15 competing standards. So that's the current situation. Still, you don't need to create new standards, you need to use the existing standards. But the question is, they don't always align. For example, here I mapped a few standards. The first one is IFC from Building Smart. ISO standards, well looking, but not sufficient because you also have the 81346, the reference designation data for the functional requirements, which are not covered in IFC. And on the right, you have ISO, well, the typical PSCS standard, one family of STEP standards to cover the life cycle. And the key here for proper asset management is to find the links between the different standards and not reinvent a new one, but find the links between the standards to use them all in the same time. I'll skip this slide because this is the way we organize standards internally with our software platform ShareSpace. Please come back to me with the further questions, but I'll focus on this example we developed for Aegis, where we provide at the bottom the reference data. And this is a condition-based maintenance system for the railway in Lyon, a bigger city in France. When you have the incoming system from incoming message from Voslo from the monitoring, registering a problem in the global PLM platform, and then we are able to send messages to the CDE, the Common Data Environment BIMsync, which itself wants Power BI, which provides an up-to-date dashboard with the health of the system, which we registered. We can exchange information with the Power BI, but we can also trigger review, on-site review with a Smart Vigie, which is a mobile application. And this on-site review gets results, which triggers a work order with Carl, which is the deployed CMMS solution. And the key takeaway from this slide is that the PLM platform at the bottom, ShareSpace IAM, is in charge of registering the traceability for all the interventions and all messages in the asset, so that we can get back in the past and explain what happened on the railway and get some statistics from what happened. The next few slides, I'll cover what open standards can help to manage the extended enterprise, because thing is, as you all know, with the railways, is that you don't have a prime with subcontractors, you have a federation of actors. So globally, you're facing the extended enterprise problem. Why extended enterprise? Well, if we can organize BIM, Building Information Modeling, it's part of digital engineering, which itself, it could be seen as a part of data lifecycle covered by PLM, which itself is actually only a part of the extended enterprise. Extended enterprise being all the exchanges between the different actors in charge of the same asset. And by the way, I point you to my blog post why I'm done with BIM after more than a decade and now focusing on PLM, because BIM is just PLM for buildings and built assets. Really, the key concept here is to focus on the extended enterprise, where the partners exchange information with traceability in mind and work with compliance in mind. One really key standard to implement this extended enterprise way of working is the ISO 19650 information management using building information modeling. 3 figures on this really strong and stable ISO standard. This first one, which shows that this standard is about quality management. As you can see here, it's embedded within the ISO 9001. And then you remember ISO 55000, which is asset management. And this is a sub part of this global standard family. 9650 is a way to organize information exchanges between partners for built assets. And here you have the famous puzzle piece where you have the global, the stable wheel, as we've seen a few slides. When a project happens, or remodeling project, or the change request happens on that stable wheel, the A here shows that some of the asset information is taken as a snapshot to feed the project phase, which itself, when finished, feeds the asset information model. So this is not a clear cut between asset information model and project information model. The two are interacting. So that's the first figure. The second figure, really important figure to remind, is this one, which I won't go into details, but you can take as a takeaway that this organizes the requirements between the appointing party, the appointed party, which is the provider, and those requirements are meant to contribute to the asset information model on the right here. And finally, the third figure here is all this work, coordination works, requires a few labels or a few gates to pass. Work in progress is not shared. Work in progress data are could be shared within the contractors. Then you check this common repository of the data. You review and then you approve. Once approved, it's becoming shared, and that's part of the official ISO definition, shared among the different partners for that building or asset management program. And once reviewed and authorized, this shared information is published. So the circle of parties accessing this information is broadening. And finally, in the end, you have the archived status, when the information doesn't need to be shared anymore because it's either superseded or deprecated. The key here is to take note that all this takes for granted change management or versioning or time, and this ISO 19650 doesn't force you to use any specific change management system. This is why the other standard I would like to emphasize today is PLCS. PLCS offers you the way to accept the fact that your design system will be supported once deployed in the wild, and you need to find a way to organize the data to make sure it's properly maintained. An example here with aerospace example with a reactor or turbine, whatever, consider a product. Your product definition is designed. Then your product, once design is created, it's assembled, it's manufactured, and then it's deployed in the wild, it's operated in the wild. But that's your unique serialized product, the instance you created from the design. But then it needs to be supported, and the support needs a methodology. That's the support design, which is applicable to any instances. And then you have the history of your own deployed asset, which is maintained, which could differ from the support design. So that's the reality. And this standard PLCS takes this for granted and offers a data model which enables you to support this and to implement this and to trace the changes, because all these steps are happening in real time, in the loop, and are not synchronized. A design change could be pushed into production, whereas your asset is already maintained. And the support system could be also changed while the design has been also changed. So you need a way to coordinate and to connect the different wheels here. And this is exactly what PLCS is meant for. So that's the second ISO standard, really important for asset management in digital twins. As a whole, a trend, smart standards are becoming smart. Smart as for standard, machine applicable, readable, and transferable. This is a diagram from ISO. From on the left, the paper, dumb paper, to on the right, future extensions and smart standards. The key here is to focus on the semantic arrangement of content for selective access. We're making sure, and that's a very strong and global movement in the standards, we're making sure that the standards can be human readable, that's a minimum, but also machine readable, so we can implement reasoning on that, and we'll cover that in a few slides. Two examples, running program running in Sweden with the SIA. We have the domain information resources, and then the domain content on the right, and domain, we define an industry domain ontologies, and that's, I'll go through the bullet points. This new ontology IDO is meant to connect the different standards because it's an upper ontology, meaning it's generic enough to be compatible with all the standards, specific enough to be compatible or applicable to the specific industrial domain, but it's meant to be related from every other standards, and that's the key I was hinting in the past slides. Another example where this is happening, national guidelines for Sweden as well. Here we take into consideration IFC, the 19650 I just spoke about, and the co-class, which is a classification. And here we may have the perfect storm because one of the standards is process oriented, the other one is really focusing on file deliverables and not data. The granularity is not the same. And the third one is focusing on classification. How do you put those three philosophies in the same standard? And that's what's happening with this running program. We're implementing, of course, this with the shared space IAM I just mentioned. And we also use the IDO ontology to link to different standards. Now, it was too long, you didn't read anything, and you need a few key points. Here there are. The key takeaways I would like you to take away with you today is first, asset management requires change management. There's no choice. You need to require change management. The second one is the impact analysis relies on data consolidation. You can't do any impact analysis if you know that if all your data are not aligned. Third one is digital twins must leverage semantics alignment, and that's the key to use multiple standards in the same time. And then standards are becoming smart to leverage machine reasoning, and this is not big data. This is a small data, but semantics data. And finally, adopting standards can accelerate the systems to system connection because let's face it, your asset, a railway station, power system, they are just system of systems. You need connections, and for that, you need to leverage standards. And I'll leave you with this slide, which I love. Information-centric, you need to be information-centric instead of file-centric. Rich information models based on standards, obviously. You need consolidation, that's the ability to superimpose and consolidate data sets. And you need to control the data sharing because in the extended enterprise, everyone is partner, everyone is not friends. You also have competitors and you have security rules. So you need to control what data you share. But that's it. I'll leave you with this and open for questions maybe in the end of the webinar. Thank you.
Thank you. Thank you very much, Silva, for this wonderful presentation. I think it's a very holistic view of and very impressive. And also very pedagogic. Thank you for the funny drawings. And I don't know if there are some questions to you.
There are no additional questions from the chat, but we had already prepared two questions. Maybe.
Yes. Maybe I can say, Sylvain. Okay, you show a very large picture and very. What do you think about today the level of adoption of the digital twin due to all the facts you explained and all the bricks we need to consolidate, and in this landscape of large standards, and what for you will be the next development priorities? Yeah.
Oh yeah. Level of adoption is really diverse. You have big players claiming they adopted digital twins ages ago, but when you dig a little, you realize they only captured the digital models side of it. So that's a little deceiving. And you have medium players like engineering firms like Sistra and Aegis, we just covered, which really understood because they are facing all the coordination, collaboration issues. So they were among the first to really capture the value of the digital twin and the controlled data and shared data. And I think they are really at the high end of the adoption. But this is really spreading. The big players are catching up, and the small players, the SMEs, are really playing a good game here, and that would be probably an answer to the second question.
Exactly.
SMEs cannot focus on everything, but successful SMEs are focusing on one aspect. Would it be semantics and alignment? Would it be controlled data, or going from unstructured data to structured data? Digitizing topological networks, or digitizing PBIs or pipeline networks, and providing semantically rich information is a very active domain right now. And I would say that the next development priorities is really deployment, and it will be based on the second wave. And the first wave was all the promises from the bigger players, bigger platform software vendors. These are being deployed. We have some lessons learned, and now the next development is to pick a few shortcomings and also failures of these initial platform deployments, and to focus on those critical assets. And this is where the SMEs can contribute, because they are not in charge of the full spectrum of the use cases, but they can focus on one or two specific use cases and clearly state their added value. So that would be my advice, to clearly state the added value, limited to a few use cases, and then the medium sized and the big players will notice for sure.
Okay. Thank you very much, Sylvain, for this and answering the question. So,
my pleasure.
Well, with all this, I think, as I said, we are running lack of time, and it's perhaps lunchtime. I don't know. It's maybe we move to the next and last presentation. That will be a video. And for your questions, we will not perhaps, as I say, answer it directly, but you can put it in the chat, and we'll answer after that. Okay, so we start with this last presentation, if I can launch it.
Yeah, for those they have no time to follow the video, please be sure that the session is recorded. That the session is recorded, and we will provide you the link to the recording as well, for sure.
Sorry, Lutz, because I missed what you say.
Yeah, no.
Oh, it's okay. I launched the presentation because it was.
Yeah.
Okay, so I will, I think, share it now. Tac.
Yeah.
I hope you will hear it well. It's okay.
No, I hear no voice.
Okay. You cannot hear it?
No. If we cannot hear it, I could imagine that we will take this video as it is to our STARS YouTube channel.
Yeah.
Yeah, and then you will be able to follow also that video. Maybe Florence, you make a short summarize of that video. That would be good.
Okay. Just saying some few words. I think yeah, you will see both application about what we call the digital twin and how to succeed in this kind of project. And on the other side, there is another presentation showing some digital twin for the railway application based on artificial intelligence and highlighting some application and challenging under this. So I think maybe you can view this video more easily on the Basecamp Lutz.
Yeah, or on the STARS YouTube channel.
Or on the STARS YouTube channel, if it's okay for everybody, because
we can prepare it afterwards because the recording of this webinar is also available on the YouTube channel of the STARS project, and the link to the YouTube channel is already indicated into the chat. And so that everyone can follow.
Okay.
And if I make the follow-up mailing of this webinar today, I will provide you with the link to both videos so that all would be good. I saw this video already yesterday, but it's very interesting, and it's worth to be shown or to be watched. Yeah, for you.
Yeah. Yes. Thank you very much. Because it takes around, I think, 25 minutes.
Yeah.
So I think it will be more easy for everybody here to look at it when comfortable. Okay.
Yeah. What I can do is I have some information around the next activities of the STARS project. Nowadays is running that is the hint to the STARS project YouTube channel, which is available following by this link. It's already indicated into the chat. Then nowadays, for that moment, the STARS Hack and Match number 4 event is running on artificial intelligence and digital twin. There will be a final closure meeting at 5 p.m. I do not have the link for the moment, but maybe someone can investigate. Maybe Amelie, you can put the link into the chat of the STARS Hack and Match number 4 closure event this afternoon. Then next STARS Hack and Match event will take place in the beginning of September. On the general topic, advanced technologies for resilience of the supply chain. For sure, you are invited to indicate your challenges very soon. We will keep you informed about the links, how to reach the call for challenges. And I think as soon as we'll be ready, I will inform you by mail. Then we have the same information will also be updated on the STARS Hack and Match events meeting platform. And if you are interested to join the meeting platform, it is on you to set up a small profile, and then you have the chance to get in contact with other participants of the platform. You could also use the marketplace function in order to define products which you could provide to ease the discussion with the other participants. Then we have some more STARS tutorials in 14 days. On Friday in 2 weeks, it's on switching to green technologies in railway. It's a bit later than today, 1:30 to 3 p.m. And registration is already possible. Then we have a very new STARS tutorial, which will take place after the summer break on the 6th of September from 11 to 12, maybe 12:15. Maybe I will arrange change the end of the webinar a bit to 12:15. It's on AI in safety critical railway applications and especially on validation and homologation issues. Registration is also already possible, and this webinar is organized by Fraunhofer Institute, which is one of the partners. The webinar before is organized by Technopark Istanbul, also one of our STARS partners. And the last one is organized also by Fraunhofer Institute on smart sensors and communication technologies for railway applications on Wednesday, 13th of September